Okay, welcome. First, I would like to thank everyone for taking the time to join us today. We are very excited that you're here and we're looking forward to sharing some valuable information with you. So just a couple of quick housekeeping items before we get started. You should see a chat window available in the Zoom app. All attendees will remain muted throughout the session today. However, questions are encouraged. So please, if at any point during the session you have questions, just submit those via the chat window and we will reserve time at the end to answer those. All right, so again, welcome to our webinar on AI-powered database automation. We understand the challenges and pain points that come with critical database operations. So we are very excited for this opportunity to walk you through how several nines ClusterControl can automate all facets of your open source database management, particularly running in the Vultr cloud. So without further ado, I'd like to welcome our presenters today. We have Mike Biondi joining us from Vultr, and from several nines, we have Prim, who will be guiding us through today's session. So thank you both so much. And Prim, I will now hand it over to you.
Thank you, Sarah. I hope everyone can hear me okay. Welcome to the webinar again. I'm going to kind of walk through the slides here. And the topics that we'd like to cover today are basically kind of going over what is ClusterControl, just to give an overview of what it is. And then also help understand how does ClusterControl help DBAs in their day-to-day tasks, and how does it sort of minimize and automate a number of the mundane tasks that typically are expected of DBOps folks. We'll walk through concrete examples about deploying sort of a complex MariaDB cluster, and also talk about how one can import an existing cluster into the management portfolio of ClusterControl. We'll also walk through how ClusterControl helps maintaining really high uptime for databases through the auto recovery and auto failover mechanisms that are built into ClusterControl. Finally, we would also like to talk about some of the really critical aspects with respect to uptime and sort of things like backups and how ClusterControl helps automate taking backups on a scheduled basis or otherwise, sort of ad hoc backups. And also, once you're done with these sort of disaster recovery capabilities, how ClusterControl also helps with scaling an existing database without having throwing extra infrastructure at it, using concepts like load balancers and proxies in front of databases. We'll also talk about DR, where you can how ClusterControl helps deploy, read replicas in remote data centers, or bring data close to reporting applications, and so on and so forth as well. We'll also talk about proactive alerting. This is really critical. You want to know if a database has failed, or there are some critical KPIs that are reaching or crossing thresholds. You want to be alerted so that you can take proactive action. So how ClusterControl helps with that. And then we'll also talk about some benchmarks that we did on Vultr Cloud with respect to MySQL, and we'll talk about what those how those benchmarks performed and so on. And finally, we'll talk about where you can find ClusterControl, which is currently available on Vultr's marketplace. Okay. So the format for the webinar is we'll talk about, I'll present a slide and then actually then cut over to an actual demo sort of in line with the slides. So what is ClusterControl? It's basically a tool that automates a lot of the operations and monitoring and management of open source database clusters that you may have. So ClusterControl is able to manage, let's say one cluster or thousands of clusters that you may have in your enterprise. So it makes it really simple, and you basically want to think of it as a tool that augments your existing tool set to manage and make it super easy to maintain, manage, and most importantly, secure. And also from an uptime perspective, it's always up and running for your applications that you may have, which may be really mission critical for your end customers and so on. So that's typically that's essentially what ClusterControl is. And how does cluster control, help DBOps people, right? So it has a number of different aspects and components that typically helps the DBOps people. One of them is deploying the database. So it's super easy using cluster control to deploy a database, a brand new database cluster, or to import an existing cluster into cluster controls management and monitoring purview. It also supports really high uptimes through automatic failure detection and failover. It automates taking backups, which is a critical part of your DR strategy. It is also helps deploy load balancers to existing clusters to squeeze sort of the last bit of juice out of your database servers. It also helps with DR from the perspective of bringing data close to you, or having deploying a remote a standby on a remote data center and so on, and also complementing with all these functions, alerting, and also some rich visuals that help you understand, help with capacity planning, and also understand how your database is performing over time, and also to sort of visualize some of these interesting KPIs from a database perspective, and also from the actual hosts that are hosting those database servers. So first thing is with respect to a database cluster, either let's say today, let's say you want to deploy MySQL or Maria or Postgres or Redis or MongoDB cluster. Typically, what you have to do today is you have to go procure a VM. You have to set up the operating system. You have to download the packages for the respective database. You have to figure out how to install it, how to configure it, how to tune it. How to secure the database. You don't want to open it up to the entire world, right? So you want to make sure it's locked down from a security perspective. You have to then figure out, okay, how am I going to do backups? How am I going to schedule that? Where do I need to write scripts for this? Like cron jobs and so on and so forth. So it gets really complex, as you can see, the various steps that are involved with deploying and maintaining and managing a database. So let's now walk through and see how easy cluster control makes this entire set of functions. So I'm going to navigate to the cluster control terminal here, and this is the front end for cluster control. It basically has two components. One is the UI that you're seeing here, and the other piece is the cluster control backend, which does most of the hard work behind the scenes. So the first thing we want to do is deploy a database. So I'm going to walk you through some steps. So here, there are a few options that are presented. I'm going to choose the deploy option. You also have the option of importing an existing database into cluster controls portfolio here. So I'm going to use the deploy option, and I'm going to pick MariaDB, MySQL MariaDB cluster here. So I'm going to give it some credentials here, and I'm going to call it give it a name for the cluster. And I could add some tags if I wanted to, but I'm going to skip that step. And then here I'm going to pick the version and the distribution of the cluster. So with respect to Galera, there are two options: it's a Percona XtraDB cluster or MariaDB Galera cluster. So I'm going to pick the Percona one, but you're free to choose either one. And then I can pick the version here as well. And once I've done that, it's basically presenting a password for the MySQL root password here, and then adding the set of nodes that will make this Galera cluster. So I'm going to add in 3 hosts here. So with Galera, as you may already know, you need a minimum of 3 nodes to provide sort of an odd number of nodes to provide adequate quorum. So I'm going to enter the names here of the hosts. And finally, I'm going to click deploy. And what's going to happen now is cluster control kicks off a job behind the scenes, as you can see here. And the job is basically running to, and you can view the job. Here, there's a job that's running. It's essentially now sort of bringing the operating system up to date, and then installing packages and so on and so forth. So this is going to take a few minutes, and this database will be up and running. So while that's happening, let's actually also deploy a MongoDB cluster as well. So here I want to pick the MongoDB replica set. There are other options you can set up MySQL master slave replication, timescale or Postgres database. You can also pick Mongo shards, Redis, and SQL Server as well. So I'm going to select MongoDB for this case. And I'm going to give it some credentials here. I'm going to call it Mongo. And I'm going to add the hosts finally. Actually give it also a password as well. So I'm going to call it Mongo admin. Oops, pardon me. And give it a password. And then also then give it the nodes as well, the hosts for the Mongo replica set cluster. Going to do that. And hopefully this is going to be up and running quickly. All right, so I'm going to click deploy to deploy the database. I can also pick one of these versions here as well. So I'm going to pick the default 4.0. I can pick 5.0 version as well. And also with the distributions, we can pick the MongoDB distribution or the Percona version of the distribution as well. So I'm just going to pick 4.4 here and click deploy. So that's it's going to do the same functions. You know, there's a job that's get kicked off behind the scenes in ClusterControl, and that's working towards deploying the database. While that's doing, let's actually navigate and see, you know, an already created Galera cluster that's been spun up. So the interesting piece is the topology here. And if I navigate to the topology, this is sort of how the MariaDB Galera cluster would typically look like. It's a multi-master setup. That's what it's known for, and as you can see here, it's basically presented here. So let's then now go on to the next slide, and talk about. So let's wait for those databases to come, to come online. And while that's going on, I would like to then talk about auto recovery through ClusterControl. So ClusterControl also provides the ability to automatically detect failures in your clusters and promote a standby to be the new active primary database. And ClusterControl is a mature product. It's been in the market for about 10 years, and this failure detection and failover mechanisms have been perfected over those years of experience. So this is really important from an uptime perspective for your applications that are using the database to store and retrieve data from. So for this portion of the demo, what I'm going to do is I'm going to navigate here to the clusters here, and I'm going to fail over some clusters that I have already set up. So for example, on the MySQL side, I have a MySQL master slave replication set up. So there's a master called MySQL-1 and a slave called MySQL-2. So what I'm going to do for this part of the demo is I'm going to fail the master by shutting down or rebooting the host where the MySQL server is. And what ClusterControl is going to do is it's going to detect the failure of the master, and it's going to automatically promote the slave to be the new master, and then we can see what we can do with the slave after the fact. So I'm logged into the MySQL-1 host, and I'm going to shut it down. And that's sort of issue the shutdown command, and now we should see a immediate response here by ClusterControl. So as you can see, there are a bunch of alarms that are being created from the perspective of the failure of the node itself. So the node has been shut down, it's rebooting. While that's going on, ClusterControl has detected a failure of the master, and then now it's going to start, it's going to work towards promoting the slave, the previous slave as a new master. So while that's going on, I'm then going to navigate to another cluster on the Postgres side, and sort of perform sort of the similar function here. So here we have a Postgres master slave set up with PG bouncers and HA proxy. So what I'm going to do is there's a host here called PG1. I'm going to shut down that host and allow ClusterControl to promote the slave to be the new master. And these are all options that are available to this auto recovery function. You can either turn it off, or it's currently turned on. That means if the master fails, ClusterControl will automatically promote a slave to be the new master. But you also have the option of turning this off, meaning you don't want auto promotion by ClusterControl. So that's an available option for you. So now I'm going to do the same thing as I did with the MySQL option. I'm going to shut down or reboot this host here. Reboot the Postgres master in this case. So I just issued that command. And now as you can see, ClusterControl immediately detected PG1 being disconnected, meaning it has gone down. Now it's working towards promoting the slave to be the new master. So now let's navigate to the MySQL cluster and then come back to this. So if I go back to the clusters and look at the MySQL master slave replication and click on topology here, as you can see, the MySQL 2 is the new master. It was previously the slave. It has been promoted to the new master. And the old master has been essentially the MySQL daemon on that host has been shut down. That means your applications cannot connect to that server to write data to it, which is typically what you want. So you have the option of now rebuilding the previous master as a slave of the currently or the other new master. So this option, rebuild replication slave, will help with that. So what I'm going to do is click on that option and then select what is the master that I'm going to use to rebuild the slave off of, and then click on proceed. So what ClusterControl is now going to do is automatically do all the necessary work that's required to rebuild the MySQL 1 as a slave of the newly promoted master. So that's as you can see, it's pretty much automated in terms of how that's done. So if you typically envision how this is done in you would have to do it. You have to write scripts to do take a backup, restore it on the standby, set up replication, make sure it's in sync, and all that is pretty much automated by ClusterControl. So while that's happening, I just want to navigate back to the master slave replication of MySQL, the Postgres, and see how that's functioning. So here, as you can see, Postgres 2 has become the new master, and it's ClusterControl is now working on making the old master as a new slave, and it's going to take a few minutes for that to come online. All right. So that's from the perspective of how ClusterControl provides really high uptime through auto recovery and the ability to rebuild slaves from failed masters as new slaves to an existing cluster. Now I'm going to go back and sort of view the clusters that we spun up at the beginning of the session. So we set up a Galera cluster. So I'm just going to navigate there and show the Galera cluster that's pretty much being built and that's available. So this Galera cluster is still ongoing. And if you look at the jobs for this spec here, it would show that it is still building. So let's give it a few more minutes for that to come up, and then look at the Mongo cluster here. So the MongoDB cluster, and if you look at the topology, here's a MongoDB cluster that's been rebuilt, that's been built from scratch, and that's become available for your applications or for you to start using. So basically, essentially, ClusterControl has taken over all the functions that's required to set up this this cluster. Okay. Once you have pretty much done the auto recovery piece, the next portion of this webinar is how do you automate taking backups, which is a really critical and important part of your DR strategy. So and we'll here see how ClusterControl has scheduled mechanisms that will take either full backups, either binary or logical backups, and also incremental backups as well. And you can pretty much automate this and also talk about some interesting options with respect to how ClusterControl helps verify backups that are taken immediately after the fact. And that will give you confidence that, God forbid, if you had to restore a database at some point in time due to some issues, then you actually have a backup with good integrity that will actually, is going to work for you. So let's navigate there and see how ClusterControl helps with that. So I'm just going to navigate to this MySQL cluster here and to the backup section. So here we have already taken a backup. So the next, so we can now, restore that backup or create a new backup. So here, when you do in the backup section, there are two options. You can create an ad hoc backup, or you can do a scheduled backup. So, for example, let's do a scheduled backup. So, if you navigate through this wizard, there are a few backup options. You can do a logical backup through MySQL dump, or take advantage of XtraDB backup, either full or incremental. And you can have different schedules. You can have one-day schedule for full backups, and then hourly schedule for incremental backups so you can have that sort of a schedule. And then you can actually specify the which host you want to take the backup from, or auto select, and so on. And then you can specify whether you want it to be the backup to be stored on the node, or you can specify a shared NFS mounted directory on each node, which will then be used to store the backup. One also has the option of uploading backups to object storage in various clouds as well. So the really nice aspect that I'd like to call out here is this verify backup option. So this is really comes in handy, because it's great that we take backups, but what good is the backup if it's corrupted or something like that? So this essentially, coupled with allows ClusterControl to restore the backup on a VM that you provide, or host that you provide, to verify the backups and to actually alert you saying, hey, the backup was good, or the backup was not good. So I'm just going to do that here. Okay. Let's go back to create an ad hoc backup. So let's do an ad hoc backup here. Let's say I want to do MySQL full backup. I can store it on the node in this particular directory. I can continue and say, create the backup here. So what that's going to do is it's actually going to kick off another job to create the backup, and then we'll essentially alert you once you have the backup. But once you have a backup, you have the option of restoring the backup, and there are a few options that we provide. Is you can restore the backup on a node, because if this is a development server, then you may want to just restore the backup on the same node and bring up the database, or for example, go back to yesterday's data or something like that. Or you can restore it and create a brand new cluster from this backup as well. So there are a few options that are available from the backup perspective. You can also set up sort of standard backup parameters, things like retention, either on the local node or on the cloud retention side as well. So the backup is still running. And the same thing applies for Postgres as well. If you navigate to Postgres backups, you can create backups for Postgres. You can do a full backup or incremental backup, and there are a few options. There are additional options for Postgres. There's base backup and also PG backrest, both full, incremental, and differential as well, that you can take advantage of. And the same thing applies for MongoDB as well. So we have a Mongo replica set cluster here. If I click on backups here, you'll essentially see that you can, there's one successful backup. Either you can restore the backup, or you can create a brand new backup from this cluster, either scheduled or ad hoc backup here. And you can schedule a backup there as well. So this is another key component that ClusterControl automates. And once you specify the verify option, you can be confident that the integrity of the backup is solid. And then if you need to restore the backup, it'll be available and ready for you, and you can have the confidence that it's going to work. So that's another piece of the puzzle that ClusterControl automates and allows you to focus on other critical things that you may need to do with your databases. Okay, you can navigate to the next slide here. Proxies. So this is an important aspect as well. So let's say you have a database set up, and you you'd like to squeeze the last ounce of performance out of the database cluster, right? So in that case, you can, or let's say your data, so what options do you have? Typically, you can throw more hardware at it, or you can you can make use of these load balancers or proxies that'll do things like connection pooling, performing read-write splits, depending on the proxy technology type, and so on. So that's what I'd like to talk about in this next section of this presentation. So in this MySQL replication, I'd like to go into that and talk about some of the proxies that we've set up for this particular cluster. So as you can see here, there's a MySQL cluster that's been set up, and so in front of the MySQL cluster is this Proxy SQL that's been set up. So Proxy SQL has the ability to do a couple of things. First thing is it's a connection pool, in the sense that it basically multiplex let's say 1,000 connections to your web servers or what have you, to let's say a handful of connections, or let's say 100 connections on the database side. So this essentially allows you to scale the number of applications that are actually hitting the database. That's number one. The number two is Proxy SQL is smart and intelligent in the sense that it's actually able to detect the database topology. Here, Proxy SQL understands that there's a master and a slave. So it understands, it actually looks inside the queries that are coming from your application and decide to forward writes to the master database and reads to either the master or favor the slaves for the reads. And how do you go about doing that? It's really easy to deploy a Proxy SQL. So let's do that with this Galera cluster that I've already set up. So deploying a Proxy SQL in front of this Galera cluster is super easy. Essentially, using ClusterControl, we would say we would like to add a load balancer, and in the load balancer section, I would essentially say, what's the host that I'm going to deploy Proxy SQL on for this particular host. So I have a host that's already set up. I'm going to call that host out here. I'm going to so it's the host called Proxy SQL Galera, and that's the host. And then give it a bunch of credentials here for the proxy and Proxy SQL admin and Proxy SQL monitor users. And then, as you can see here, Proxy SQL set up automatically, ClusterControl detected that it's a Galera cluster, so there are 3 masters, and you can also set up some parameters as to the replication lag. How do you want to choose between deciding where to send the reads, or typically the reads? What's your tolerance level? Can you read from a slave that's, let's say, up to 10 seconds behind the master? It doesn't apply to Galera, but that option is here available as well. So I'm all set here. And there are other proxies that can be deployed as well. There's HA proxy that does proxying at the layer 4 TCP level. And then there's also KeepLiveD that we can add to provide virtual IP capability. And I'll talk about how, when that becomes relevant, and so on and so forth as well. For MariaDB, there's an option of adding max scale as well. And you may be wondering what this garbd is. This is actually Galera arbiter node. So this is a node that you would deploy with Galera clusters. Let's say you have an even number of Galera clusters, but you want just to provide quorum. You typically are required to have an odd number. So you would deploy, instead of deploying a MariaDB Galera cluster node, you would just deploy a Galera arbiter node that will then function as a node to just provide quorum for your existing even number of Galera nodes. So that's what that is. So I'm just going to scroll down and click on deploy here, and then ClusterControl, pardon me, do that. Okay, so ClusterControl is now deploying the Proxy SQL for this Galera cluster that I have already set up. I have a few Proxy SQLs deployed for this existing cluster. So let's actually navigate to the topology here. So as you can see here, this MySQL is essentially set up, and Proxy SQL understands the topology. So once Proxy SQL is set up like this, you can also, as I mentioned, deploy KeepLiveDs on these hosts that will provide virtual IP capability, and that will provide high availability at the load balancer tier as well. Let's see how these nodes, Proxy SQL nodes, can be set up to do read-write splitting, and also things like favoring one slave over another. For example, you could have a topology where there's one master and two slaves, but one slave is in the same data center, but the other slave is in a remote data center. So for the applications that are hitting the Proxy SQL, you may say, I would like to favor reads coming from the slave on the in the local data center versus reading from a slave from a remote data center, because that's going to cause latencies. So here on this nodes tab at the bottom, there's a section for Proxy SQL nodes. So there are two nodes that are here. I'm just going to click on one and talk through how you would typically set up Proxy SQL to favor one node over the other, or by assigning weights and the like, and also figure out how to do read-write splitting. So this Proxy SQL has a bunch of rules. So first one is what we call group 100. That is essentially the read-write group. So it basically filters on these sort of functions. So Proxy SQL is an intelligent proxy in the sense that it actually looks inside the queries that are coming to the database, and then decide, okay, so this is a read only, and then sort of redirect that query to one of the slaves. Whereas if it's a write, then send it to the master. So that's what the read group 100 is. Pardon me, the group 100. The group 200 is typically the read-only functions. So I'm going to navigate to the servers tab. The servers tab calls us out, in much clear fashion. Here there are two host groups. There are host group 10 and host group 20. Host group 20 is what we call the reader group. So it has both MySQL 1 and MySQL 2. And the host group 10, which is read and write, has MySQL 2, which is actually the master node. So if I were to click on this configuration, and let's say you wanted to favor sending reads to one server over the other, you can actually assign the weights here. So the weights will allow or tell Proxy SQL to send read queries. If it had to determine, so where should I send this? Proxy SQL will determine to send the reads to the read server in the pool, to one of the ones with the highest highest weightage. And so let's say you want to assign 100 to this, it will essentially send it to this server versus the other one. If they are equal weighted, in this case they are equal weighted, they both have weight of 100, weight of 1. Then Proxy SQL will basically do sort of a round robin fashion to sort of route the read queries. And you can change them to suit your needs as well. As I said, if you have multiple slaves here, you can favor one over the other. You can basically say, I don't want to send, you can remove the master from the read group at all. Let's say you don't want to tax the master by sending any reads to it. You can actually remove it from this group altogether, in which case it will only send writes to the master and will send the reads to the pool of slaves. So that's typically Proxy SQL. Let's actually now navigate and see how the setup of Proxy SQL has come up in the Galera setup here. So this is the node that I added a Proxy SQL to, and voila, there's a Proxy SQL now that's sitting in front of the Galera cluster. Now your applications can connect to Proxy SQL, and Proxy SQL will determine how to route read and writes to the available set of servers, and then you can actually configure them as well. Let's say with MariaDB, with Galera, you are sort of it's best practice to, let's say, send writes to one server. So in this host group, if you look at the groups, host group 100 or 10 is actually the read and write. So if you navigate to the servers, you can say for this one here, which happens to be the read server, host group 20. So you can say, I can read from all three, but I want the writes, which is the host group 10. You can say, I would like to send writes to one server or two servers for each, just so that, if one fails, you have a backup. So you can remove the third from here. Let's do that. And then you can then say, I would like to favor one over the other. So you can say, I want to favor Galera 1. So you can assign it greater weights here and essentially save it. And so now in this case, what happens is when Proxy SQL detects writes, it's going to send it to this Galera 1 node, MySQL-Galera 1 node. And if it's read, it's going to basically round robin between these. And if Galera 1 were to fail for some reason, it has a backup node for writes. It's going to send it to Galera-2. So you have that backup capability in here, sort of like a backup server to send writes to in the event that the Galera 1 fails, Galera 1 node fails. So that's typically how you can take advantage of deploying Proxy SQL or for Postgres. You typically, you would deploy a couple of options that we have available, the PG bouncer. So you can, here, this particular deployment of Postgres has PG bouncers that is set up. That's along with HA proxy and keep alive D. So these tiers provide high availability at each of these tiers. There's high availability at the load balancer level. There's high availability at the node tier as well. So this actually covers the entire gamut of providing you really high uptime and availability for your applications. All right. So moving on to the next slide here. Read-only replica. So this is another important piece of the puzzle as well. So let's say you have a cluster set up that's working great, but you have a reporting team in another part of the country, and you want to bring the data from your database close to that reporting team, or let's say you want to have a greater disaster recovery capability. That let's say if the primary data center were ever to fail, you have a couple of options. You can restore from backups that you already have and bring up a server. That's going to take some time, right? Depending on the size of the database. Or you can have a read-only replica running in a different data center, and then you can immediately promote that, add new slaves to it, and so on and so forth, all through ClusterControl in a sort of a seamless fashion. So adding a slave to a MySQL cluster is typically super easy. So I'm going to click on this cluster here and work towards adding a replication slave. So for this cluster, I'm going to pick. I have a couple of options. I can hang this new slave off of the existing master, or I can hang the slave off of the slave that I have. So let's say I'm going to let's do it off the slave. So I have a host that is set up as well. So I'm going to add the host name here. Hit enter. So it detects that, and I don't really care much about semi-synchronous replication for this case. I'm just going to add replication slave. So ClusterControl is going to work behind the scenes to set that up, and we'll circle back to this. Now I want to go back to the cluster, the Galera cluster that we set up at the beginning of the webinar. So here's the Galera cluster. Hopefully it's up and running now. So let's actually click through and see. And voila, here is the Galera cluster that we set up at the beginning of the webinar. And ClusterControl has done all the hard work in setting up the nodes, setting up Galera, setting up the multi-master replication, and doing all that complex work on your behalf. And you can actually see the performance of the database here as well. Well, it's a new cluster, so not a lot of data available for you, but we can actually look at that with the existing cluster here. So if you look at the dashboards, there are a bunch of options that actually provides useful information. So let's look at the dashboards here. And yeah, there's not a whole lot of activity going on, but you can see the replicated bytes and that sort of information, but we'll circle back to that in a second. Okay. So as you can see, setting up a slave is really easy. And with a couple of clicks, you should have a slave. I think that job is still going on. Let's circle back to check out the progress of that. You can actually check it here when you go to the job section. So it's the adding a new slave process is continuing on. So let's circle back in a few minutes. So while that's going on, let's actually navigate to the next portion, which is database advisors. This is a nice functionality that's provided by ClusterControl. So ClusterControl, let's say you are importing a database that you have already deployed in your environment, and you want to sort of bring it into the management purview of ClusterControl. ClusterControl has a bunch of advisors that typically runs on a regular basis, sort of once a day or whatever schedule, typically the cron formatted schedule, and it checks for the database to conform with certain standards, like certain best practice standards. So ClusterControl supports advisors for security advisors, schema advisors, sort of a query advisors, performance related advisors, advisors that help you with capacity planning. Let's say, for example, your disk size has been growing at a certain rate on a weekly or monthly basis. So it kind of tells you, you have a runway of, let's say, 30 days with the current storage. And then after, you have to, in between now and 60 days, you should start, considering or planning to add more storage, because if not, you basically run out of storage. So those kind of, useful advisors that it basically has built in to ClusterControl to, again, help towards, keeping the database up and running, provide, highest possible uptime, or another way of looking at it is, minimizing downtime for your applications. So let's actually navigate and see some of the advisors that are handy. So I'm just going to go into the performance section here, look at advisors. So under advisors, there are a bunch of advisors that ships out of the box. You can also change these advisors using the developer studio that we have built into this UI. So you can take these advisors and actually customize them, add new advisors as you may wish, new ones, new categories of them, and extend the behavior and extend the functionality of ClusterControl. So let's look at some of the interesting ones here. So from a security standpoint, so as you can see, there's a warning level, alert here with respect to sort of the built-in advisors running and figuring out what's wrong. So basically, I added this test user for this database, and this test user can log in from any host. So it's basically open, it's wide open. So this is typically not recommended, right, from a security standpoint and compliance standpoint. So basically, the advice is, fix this, make sure this is not %, meaning it's not, from any host. Limit the host to a CIDR range, like a private network CIDR range, or another combination of hosts where this user can log in from. So that's one of the ones. There are other ones as well, with respect to other accounts that are not using passwords. So these are things that ClusterControl runs on a regular basis and makes sure that these sort of things haven't crept into your existing databases, with the interest of keeping them secure and always available. So let's actually click through the schema ones. So here are a bunch of options that are available to take a look at. One is tables without a primary key. This is actually, it's not best practice, but you can have it, but it's typically not best practice. So, this advisor has kicked in because, I have a table in this database that actually is of the MyISM engine. So you basically want to convert this. Pardon me, you essentially want to, pardon me, there's no primary key for this case. So you want to convert this to, add a primary key to this table. And there is also other options for checking with, tables that are MyISM only. So this is also not recommended. And if there are tables that are MyISM only, you want to essentially, convert them to InnoDB tables, right? So that's some of the advice that we provide. Then also there are ones at various categories. Say for replication, there are some, advisors. Similarly for InnoDB in general, some options, some best practice options that are, that it checks against and so on. I want to also call your attention to this one here, transaction logging. So typically what happens is, you could have a scenario where there's deadlock going on within your database. So you want to catch them, if possible. And if there are some deadlocks going on, then you can actually, ClusterControl will log them, and then you can actually navigate to the InnoDB status section here. And very quickly, as you can see, you don't have to shell out and run these commands to find all this information. It's readily available to you, off the top of your hand here. So as you can see here, there was indeed a deadlock that happened. Is actually, expired because it happened about half an hour ago. And it actually then lists what happened to this deadlock. So it detected a deadlock and what transactions were involved in this. So there's transaction 1 and what it was actually doing, what locks it held. And then similarly for transaction 2, what it was doing, and what locks were held and so on. So this is actually a really convenient way of troubleshooting these sort of, nasty ones that could show up in your production system. So you want to catch them, as early as possible and trying to figure out, okay, so you essentially know from here what sequence of transactions are causing and what rows are being locked and why and so on. So basically, sort of restructure your SQLs so that these sort of deadlocks don't happen in your production systems, and therefore by extension, keep them up and running well. So this DB growth is another advisor as well. This essentially helps determine, so how has your database grown over last 30 days or 60 days or last year. So you want to keep an eye on this and figure out how much runway do you have with the amount of volume that you've allocated for the database data files. So this actually gives you a good view of anticipating and figuring out what sort of runway you have for the databases. All right. Actually, I just want to quickly navigate to the alarms and proactive alerting section. So it's nice that ClusterControl catches a lot of this. For example, replication lags, bad security functions, or bad security controls on the databases themselves. Tables without primary keys, or users who have wide access to the databases and so on. So it's nice that ClusterControl detects all these, node failures, promotions, etc. It's nice that ClusterControl detects them, but how does ClusterControl alert? So ClusterControl, the alerting system is configurable, and it also has integrations to a number of external and third-party, operations alerting systems like, PagerDuty, Opsgenie, Slack, email, SMS, and so on and so forth. So let's actually figure out how to set ClusterControl thresholds and alerting mechanisms for various clusters, or even global, from a global perspective. So here are some thresholds that you essentially can set on a cluster by cluster basis. So if it's a development cluster, you basically don't care that much, right? But if it's a production cluster, you may want to fine tune these sort of setups to essentially to your production system, that you want to be more conservative. For example, disk space utilization, you want to catch them as early as possible, because if your database is growing very rapidly, then you want to make sure that you have enough runway to add more volume to your database data directories. So that's that. You also have the ability to fine tune through this runtime configuration section some of the alerting. So, for example, if it's replication lag, how much replication lag are can you tolerate, and how do you want this alerting to work? Here, the default for the replication lag max is 10, and you can have setup options. What's the what do you want to do with replication? So if it fails, or if it exceeds this list, this time frame, what do you want to do with them? And so you can configure some of those alerts here as well. And also with respect to rebuilding, you have the option to sort of say, I don't want auto rebuilding of a slave. I want to do that manually. I want the auto promotion to happen through this auto recovery feature at the top, but rebuilding the slave or the failed master, I want to have control over it. I want to essentially navigate and do this from a menu item or through the through a CLI, for example. So there are some other nice configuration options that you have with respect to how you want to customize the alerting piece and also the monitoring piece as well. So actually, the final piece is I want to look at some dashboards here. So with respect to dashboards, you basically have interesting graphs on these on the database nodes themselves. So we present nice KPIs at the cluster level. So you can see what the load average on the nodes are, and so on and so forth, and disk IOPS, the network traffic. So you sort of have one place here to kind of drill down and see, get interesting information or use it for debugging purposes, right? So it comes in handy during a debugging session as well. Or you can actually look at various tiers. You can look at the InnoDB metrics specifically and see, how InnoDB is performing, or if it's Postgres, and then the Postgres, respective Postgres engines. And here there are InnoDB specific metrics that are collected that are super useful to, for debugging purposes, and also understanding the characteristics of the workload and the that you're performing against the database. The locking information is really handy as well to understand, what sort of locks your read and write transactions are taking, and so on and so forth as well. All right. Let's see. I think we're running short of time here. So let me actually, so one of the last sections is benchmarks, right? So here's a benchmark that we did on Vultr Cloud with respect to MySQL. So what we did essentially was we deployed a bunch of VPSs, which is cloud VMs on Vultr Cloud. And here, as you can see on the x-axis, there's numbers one by one and 2 by 4 and so on. So that the 1 by 1 here means 1 CPU and 1 vCPU and 1 gigabyte of RAM. So that's on the lower end of the x-axis, and the far end of the x-axis is 16 cores and 16 vCPUs and 64 gigs of RAM. So what we essentially did was we ran the MySQL benchmark on these VMs. So what we measured was the 95th percentile latency of the benchmark itself, and what sort of transactions per second and queries per second that we were getting. So that's displayed on the y-axis, and also so what's from a cost perspective, how efficient how efficient is Vultr Cloud for these type of workloads. So as you can see, the dollars per month for transactions per second is actually super small, right? It's in the pennies. Respective of whether using a 1 by 1 or 16 by 4, it actually shows up a little bit, but it's very economical to use MySQL or Postgres or these databases on Vultr Cloud. As you can see, the latency, however, there is actually sort of a exponential decay here for latency, for the 95th percentile latency. The 1 by 1, latency was quite high. It was in the seconds, and it sort of dropped down on the other end of the spectrum on 16 by 64 VM, latency was, under the 95th percentile latency was, under 100 milliseconds. So pretty good performance on that end. And also, sort of observe similar sort of behavior for transactions per second, which is shown in the yellow. It's sort of steadily increasing as you add more compute and RAM to the workload. The test driver itself was running on its own dedicated VM, and it was running on a 2x4 VM, and it was running a MySQL bench, and it was running something like we ran the tests on 64 threads and up to 128 threads to figure out where the sweet spot was for the actual benchmark itself. So, great performance, as you can see on Vultr Cloud here, and, super happy with it, what sort of a, economical system you get. So I think anywhere, the 4x8 seems like kind of a sweet spot, but, you can go either way, 8x32, 2x4, even 16x64, depending on what sort of workloads and how much headroom you want to have to sort of accommodate for the typical workloads. All right. Installing ClusterControl. So ClusterControl is currently available on Vultr Cloud's Vultr's marketplace. So you can get Vultr ClusterControl from there. You can deploy it from the marketplace itself, and then kick the tires and see how that helps you automate and also set up or do a lot of the mundane tasks that you find that you have to either write scripts or figure out how to do yourself. So essentially, super easy to get that information from and deploy and start playing around with on Vultr Cloud. So that's installing. There are some prerequisites, and here's some further reading on what sort of requirements you would ClusterControl has and how to set it up and so on and so forth. After getting it from Vultr Cloud from the Vultr marketplace. We also have some other interesting information and some documentation, or where to find this documentation. Here's some links that are shown here, and also other pricing information as well. So that essentially wraps up the webinar portion of this. Now, we'd like to entertain questions, and we'll be happy to answer those questions.
Great, thank you so much, Prem. All right, we have just a few questions here. So first, does ClusterControl provide a CLI or API to automate some of the workflows that are done via the UI?
Yes, it does. So ClusterControl, almost all the functions, if not all of them, that were performed through the UI can be done through the S9S CLI, which is available as part of the ClusterControl distribution. So setting up a cluster, installing, importing a cluster, automating backups, all that can be automated through the Server-9 CLI. Also, we have APIs as well. Pardon me. We also have public API, REST API that can be used to sort of automate some of these, or integrate with ClusterControl to automate some of these tasks.
Great. All right. So yes, again, if you have any questions, please submit those through the chat feature. Another question for you, Prem. For auto recovery, failover, promotion, is it possible to whitelist or blacklist standby or slave servers? Absolutely.
So from the ClusterControl runtime configurations options for each cluster, one is able to whitelist or blacklist slave servers. So basically, let's say you have a master MySQL or even a Postgres and a slave in the same data center, but a remote slave in another data center. For the promotion piece, you basically want to sort of blacklist the remote slave, because latency is going to cause issues, right? So you can basically blacklist the remote slave from being promoted to a master.
Perfect. All right, we just have one final question. So how can we evaluate or test ClusterControl?
Great question. So Vultr Marketplace has ClusterControl available, so you can get it from the Vultr Marketplace, or some of the links that we provided earlier. Basically, should be able to get it from there. So I'm just gonna navigate here. Yeah, so just go to serverlines.com and essentially get it from there as well.
Perfect. All right, so that is the only time that we have available for questions today, but we will be following up with everyone who attended. We'll send out a recording of the session and provide some contact information if you're interested in speaking with us or Prem in further detail about cluster control. So thank you so much, Prem, for sharing this with us today. Thanks, Vultr, for partnering with us, and I hope everyone has a great rest of your day.
Thank you.